Hello guys, my name is Arun Tyagi, and in this system design journey, let's jump into this very less discussed system design, which is for hotel booking, right? So we'll start with the user journey first, and from there we will drive functional and non-functional requirement. So user journey is actually very straightforward. That user should be able to view hotels, and obviously when they are viewing, they will give these particular things: your location, dates, number of people for they're looking for. And additionally there can be other filters, but let's keep it simple for now. Then user should be able to view rooms in a hotel. Once you received all the hotels, then you should be able to go to any hotel and you should be able to view the room. Then user should be able to see the availability, and that should be highlighted on the list as well, which is the list of hotels you got, that how many rooms are available in that particular hotel. Then user should be able to do filtering on other things, just for example amenities, tags, ratings, etc., whether pool is there, and other things. Then user should be able to book the room, right? User will definitely do payments here on the system, but we might not discuss about this aspect because that's not more important when we are talking about hotel booking system design. Then user should be able to search by tags, and this can be a design in itself, but yeah, I'll try to cover that also here. And lastly, user should be able to cancel. Now from this, if we need to drive our functional requirements, so let's just cover and keep it simple. So in functional requirement, basically we are saying that user will be able to search, see details, book hotel, and cancel. Now coming to the user experience, what kind of experience you want to give to your user. Now concurrency is important, especially when we are talking about hotel booking design, that the main aspect where you need to focus on, because it's possible that multiple users are trying to book the same hotel and same room type, right? Consistency is required. By consistency we mean that when you are saying that it is booked for you, then it should be booked. It should not be like you booked the same room for two different people and later on the experience is not consistent for the user. Finally, latency. By moderate latency I mean, especially in booking and all, it's okay to take time, but other aspects like searching and all, these should be fine. But especially booking part, moderate latency is fine, right? Availability should be high. By that I mean, even if some systems are down, there should always be backup systems, right, in your system design. So we'll talk about this when we are covering the different components, that how we are taking care of the availability. Okay, so let's cover estimations for this design. So first of all, we need some industry domain data. So for that I got some data from booking.com portal. So in total what they are, okay, let me point it to the pointer. Yeah, so in total they are having 20 million properties, right? And it includes obviously hotels, houses, and others. Then what I got is that one hotel in on an average is having 100 rooms. There are different types, but in total 100 rooms, this is the average. And also one more industry info is that booked, so 70% of the hotels are always booked for 3 nights. So this much information we required for to do our estimations. Now moving from here, so given this, that means our approx daily booking will be around, so we had 20 million, that means 20 into 10 to the power 6, and 70%, so 0.7, and this is booked for 3 nights, right? So 20 by 3, you can do that many hotels you are having, and 70% of it is booked, always. So that this will comes to your 4.5 million, right? Now, if 4.5 million bookings are happening on daily basis, that means you can get your query per second, or in this case these are like transactions per second, because you are writing something to the DB, right? And like we said, concurrency is the major aspect of this design, so let's focus on our transactions. So we have 45 into 10 to the power 5. These are our daily bookings. Then in a day, approximately we have 10 to the power 5 seconds, right? This boils down to that you are having, what do we need is we need to support 45 transactions per second. Obviously this is not high, right? So in this design, this is not a challenge. Now let's check the read side also. So this is the right side. In read side, I am taking that if I'm having 45 booking, and in worst case, for peak it can go to 100 TPS also, but that is also very small, so I'm not even worried about it. So if there are 45 bookings, that means this can be 10% of people who are coming to booking page, they are booking, right? This is a fair assumption that only 10% of the people are booking, 90% are not doing anything. So that means there are 450 people who landed on your booking page. So 450 booking page view, right? Now I'm assuming this should be 10% of how many people are actually looking for the hotels. So further, in fact, if even if I increase it, so my 4500 are my query per second for a hotel for given location, dates, and number of people. So this is how we could estimate our query per second for read and transactions per second for write. And both these numbers are not very big for the standard of the design we were trying to do. All right, let's start our estimation for database sizing. How much memory do we really need? So if we take simple example of our main table, let's call it the hotels, right? So for that, if we take very simple, that it will have an ID, then name, then the location, complete address of it, and your rooms count it will have, right? Rating, description for sure. That's it, right? So if we take this simplest table, then this guy will require 4 bytes. Name, let's say, we require 100 bytes because we are considering 100 words max. Then your address will be 200 bytes. This will be an integer, so 4 byte again. Then your rating again can be an integer, and your description can be big, so let's just say 500 bytes, right? Taking these assumptions, so it will be approximately 200, 500, 3, 800. I'm taking that max 1000 bytes just to save this table. Now, having said that, to store this for 20 million hotels, what do we need? So 20 into 10 to the power 6 into your 1000 bytes, and these are bytes. So that will be your 20 into 10 to the power 6 and 3, 9 bytes, right? So this will be approximately 20 into 10 to the power 6 KB, which is nothing but 20 into 10 to the power 3 MB, which is 20 GB. So this is just to save your one simple table, right, for 20 million records. Now, so we can say, seeing this, obviously your metadata will not be this simple, so metadata will have other tables also. So I'm saying that 100 GB is what you need to store the metadata, which will have your rooms, your hotel, and other details, users and everything. Same thing for storage. We can do simple calculation. So storage of your pictures, whatever you will store in CDN or your blob. So for photos, and there can be videos as well. So I'm assuming that one hotel can have 200 pictures, so 200 photos per hotel, right? And one photo I'm assuming is of 2 MB, though I checked this on booking.com, even best pictures are like 200 KBs, right? But I'm taking the worst case here. In that case, then total memory we will require to store photos and videos, I'm including. That's why this 2 MB might make sense, that you have 20 million into your 200 into your 2 MB, right, per photo. So this will be your 88 into 10 to the power 10 to the power 6 into 10 to the power 2. So this will be your 10 to the power 8 MB, right? So this will be your 8 10 to the power 6 GB, which is nothing but 8 into 10 to the power 3 TB, right? And which is your ultimately 8 petabyte. So if you have this big of storage required, then you need 8 petabyte to store all the images and videos as well. All right, now let's jump to the very high level design for this. So on a very high level, this is going to be there are two parts of it. One is user is trying to view. Basically, user will send that for this location, let's call it location 1, and my given date, and for n number of people I am looking for hotels. So this location service will fetch the data from your inventory database and return it to the user. Now, because I discussed it in multiple designs, this is obviously not one instance, but this is you can think of a cluster of services. Think of a AKS cluster in one region which is having multiple nodes running. So no need to go in that detail again, because we have to go in deep of this design. Now, on other side, when user is trying to do booking, basically user will send that my hotel ID, which I chose already, then my room type ID, because you chose some room, right? So your room type ID, and then dates again, that from my check-in date, this and this, and number of people. So all those details you will send again, and you will call a booking. Now when booking is happening, so booking service needs to do two things. One is create an entry for this, that I am booking for this user, plus you need to update the inventory as well, right? So when you are doing it, that means your booking ID needs to work as your booking service needs to work as a coordinator as well, right? What this guy is supposed to do is, if just in case any of this will fail, either this save or this save, then you have to transact back everything, right? So this is typical SQL requirement, right? So transaction should be complete in itself. Now here is too much work for your booking service, because this is acting as a coordinator service as well, right? Anyway, we will tackle this problem later on. Now, second thing is how we are going to save the data. So inventory, what inventory can have at the simplest level is, basically think of that what inventory will have is your hotel ID is your going to be your primary key, and you can partition the data on basis of this. We'll discuss about partition as well. Then your room type ID, right? Then your numbers, or you can just can say available plus booked count. So these are two counts you can save for a room type, and other metadata. So this list, if you are having, you can consolidate the results here, and you can show as a list of hotels rather than room types to user. That you can do here, right? On reservation, on other hand, what you will going to have is your booking ID, your obviously who is booking, so your user ID, your room type ID, and your hotel ID, right? So these are some of the things, and state and everything other metadata will come here. Now when you are doing it, think of how can you store. So basically one room is available on date 1, let's call it day 1, which is Monday, right? If you will store some count here, right, that count is for which day you have to think of, right? Then because on Tuesday this count will be different. So even to make this table, what we can do is we can have the same table for every hotel, a different table. So think of like for because normally these hotel booking systems do not give options to user to book for like say 5 years from here on. They mostly provide like for 8 months or 1 year, right? So let's just think that we are supporting 1 year. So what will happen is, if we are supporting 1 year, that means then what we can do is let me try to do it here. For 365 days, right? That means every day for the 365th day, I will create a table that for day, so a date will come here, my hotel XYZ ID, comma my room type ID, and the other things. So my now available count plus booked, right? So this table we will pre-populate every day. This can be a scheduler doing this job. If you did that much, then it will make it very simple. So you will be able to get for a particular hotel on that day how many you can say how many rooms are available. So if a user is requesting for 7 days, in that case you will simply get for date this to date whatever is the other date, give me all the room types where you are having where you can accommodate a number of people, right? So that you can get from here. So one problem will be solved with this, that how you can store the inventory. Now coming back to the issue of why I said that it needs to work as a coordinator. So if you see, these are two different databases. These are not just two tables, two different databases, and can be on same location or different location. Now when there are two different databases, you cannot simply do a SQL transaction, right? So you have to, you yourself, means as a service, have to coordinate with DB and execute it as a transaction. That is why I said it needs to work as a coordinator service. Now how that will happen, as soon as you received a request means this service received a request, you first update the inventory. That means you are blocking, and this is a DB prep you will do. Then you will do a reservation, and this is again a DB prep. Then you will do this commit, the prep which you did last time. Finally, you will do this commit, the prep which you did here. And finally, you return the response to the user. Once all this work is done, any of this, prep 1, prep 2, commit 1, commit 2, if any of this failed, that means so you have to do it again. Prep 1, prep 2, commit 1, commit 2. So you have to either fail everything, that means revert everything, or you have to retry everything from scratch or from wherever you left, right? So problems with this is, if the node which is trying to do this, if that, let's suppose it did prep 1 and prep 2 and then it failed, so the commit 1 and commit 2 didn't happen and no one else know about it. That means it will not happen that suddenly another node will pick that prep 1 and try to do the commit. It's very difficult to achieve. So we have to solve this problem also here when we are thinking of that two different databases is going to support us in this design. All right, I moved this particular piece for booking service here. And so one of the solution to that problem is that we can have a coordinator, so that particular thing we outsource to something called Zookeeper. Now Zookeeper, mostly if you guys are not aware of it, just read about it. Mostly people use it for Now another solution to that can be basically we will do data partition so that we can fit data related to inventory and related to booking into same database. How we can do that? So think of dividing, because hotels especially are, this data in itself is location based, right? So we can say that if we divide that our entire DB into different regions. So for now we can say region 1 is your East Asia, then you have region 2 your Central Asia, right? And it it can be on basis of that we already know that some of the places are obviously having your major tourism, so there is going to be a lot of bookings and a lot of properties are there. For example, Thailand, right? Or your Europe and America because of business, right? USA. So all these can be different regions, and others which are like not having that much property or tourism is not there, but obviously hotel number of hotels are there. Those we can club into one region, so that way we will divide our regions. So let's for simplicity call it region 1, region 2, R3, R4, R5, R6, R7, right? So if we divided the data, our data in these regions, then what that means, that means this partition is having your 1 dB cluster, right? It's just not one SQL database, but it's a cluster. Now in that cluster, in one instance, in one database, what you are going to have, you are going to have your region ID, right? Then your hotel ID, your room type ID, same thing which we just saw, but partitioned on this. And here your primary key can be your hotel and combined with your location, right? Second, same way you will have your region, then your hotel ID, then your booking ID and your user ID. So these two things are actually sitting in the same database, in same partition. So whenever a request is coming to our booking service, now on basis of, because every booking and every inventory request is going to have one common thing called location, right? On basis of this we will identify the region of it. So that mapping we can keep anywhere. It can be a hash function which we will basically whenever a node is coming up, we will do that inbuilt in memory, or it can be anywhere in the lookup, right? Consider that we are having a hash which will convert our location to our region ID or region code. Once you are having that, on basis of our region code, what we are going to have different connection string. That for our R1, my connection string is this C1. For R2, my connection string is C2, like that. So if I'm having this, that means my problem of having a zookeeper in between is solved. At least I don't need that zookeeper anymore. Why is that? Because I need to do one transaction into one database. And this is also a very pretty neat, clean solution. We can definitely do this for our booking problem where we needed the coordination. If we are going with this approach, then we have to think of how we are going to fetch the inventory as well, right? All right, let's just update our listing service design now, because we have changed the way we were storing the data into DB. So we have to change our design as well, so that user experience is still smooth, and latency and everything is still better for the user. So what changes I have done earlier, we had simple, our listing service was fetching the data from database. Now here the only new component we introduced is basically we are trying to introduce a cache. Now how this cache will work, first of all, it's same as when a request is coming to your listing service. If it needs to fetch from the DB, so there are different replicas, like we different partitions. Firstly, like we discussed in previous portion, that now on basis of regional basis of the location for which we are looking for the hotel, data for R1 will be in partition 1, data for R2 will be in partition 2, likewise. And every partition will always have multiple replicas. So this is replica for partition 1, this is replica for partition 2, and replica for partition 3, right? So now when a request is coming, firstly it will check that for those particular that location, and that location plus for those dates, what all hotels we are having. So when you are checking the data, when you will receive the data into this, you just need to check what is the if this data is stale or not. So what was the expiry of that data in our cache, so we can keep our data with an expiry time. So if this data is expired, right, and that expiry, we can keep a number, configurable number for ourselves. It can be 3 minutes, it can be 1 day. It depends on how we came to the conclusion of that configurable number. Finally, if this is expired, then the simple thing we need to do is now we will jump to that particular partition, we'll fetch the data, and we'll update our cache as well, right? And we will return the response back to the customer, to the user who is trying to browse for the hotels on a particular location and date. So that way, this is like read from the cache, and if data expired, then update the cache also. If a next user will come for similar dates, right, by similar I mean maybe someone fetched the data for 1st to 5th, right, next user is trying to fetch the data for 2 to 7, right? So when a third user will come who maybe wants data for 4 to 5, so we already have the data into our cache, so we will be able to serve from the cache. Now how booking changes getting accommodated? So to do that, we definitely need a asynchronous process. So assume your booking service may be sitting somewhere into somewhere here into the system. Booking system is feeding everything into a publisher, right? Here it can be Kafka. I just took for example because that's a non-name for everyone. So once booking system published that booking into Kafka, then there will be a subscriber. I'm calling it a booking subscriber. So it's nothing but a worker role. Whenever a booking is coming, one of the work which this will do is it will update the database. By update the database, this means is now because that transaction already happened into the database of booking, but if there are other things required, that booking subscriber can do. One more thing it can do is it can directly update the cache as well, right? So that you don't need to do 2 trips. If there are so many bookings are happening, and if your if data stale is happening very frequently, then you can use this subscriber to update the cache, right? And it will do other things also, like sending notifications, updating the user whether booking was confirmed or not. So all those things it can do. So sanity checks also, like normally booking systems do, that they are not asking for payment upfront. They are saying we took your booking, and after some time you are receiving a notification that your booking is confirmed. So that sanity check whether there is not overbooking is done and all those things. So rather than it is making it transaction proof, it is actually doing that, what do you say, that confirmation a moment later. So when everything is settled, then only it is transacting into the DB and updating the user later. So that booking subscriber can do that sanity check for us. Another component which is required in our reading is definitely CDN. So when you received all the hotels, you will receive link of the images of those hotels. So you will fetch the data from CDN. This is a very standard practice which we use in any other design. So it's same here, where all the images were uploaded to Blob, and your Blob service is also providing CDN. So the user will read the images from CDN directly into the client, whether it's a mobile app or a laptop browser, right, or a system browser. So this is how our listing got updated now. Cache for fast rendering, and replicas of our partitions, which is required for disaster recovery and all other aspects. So you have to have replicas in a standard system. Now let's check what exactly you can store in this cache, right? How it will look like. So we know we need to support two kind of things. One is listing, when you are giving a date and a location and number of people, then you are expecting a list of hotels right on the front page. And second thing is, when you are going inside the hotels, then you are checking types of rooms, right, plus the occupancy in that and availability, obviously. So first, listing is a bit challenging because it's too much data. You have to have different rooms, occupancy in that location and everything. So let's just think of that first, that how you will build cache for listing with obviously inventory, right? So one thing we can do here is, because in Redis mostly and in cache mostly, you don't think of multiple columns. Like column 1 can be your partition key, column 2 can be your row key, and that way you will be able to combine multiple things. If you will think like that, then it will be difficult to build the cache and work on it. This is a proper database. We have to go very simple with the cache. That means your data have to be structured like a key and some value. Now to build a key, what we can do is, one thing is, we can have our key like first your location ID, combine it with the date. So that's it. One more thing we can do here is, with this you can combine location, date, and minimum occupancy. So like min occupancy. So if these three things you combine and keep this as key, then I think in one go you will be able to find out all the hotels which you can show this to this particular request to particular user. So it can be location 1 for 23rd of whatever, that entire date, plus minimum occupancy means I am booking for 3 people, right? Then all the rooms with 3, 4, 5 can come in this, in whatever value will be there, means this will be obviously an array of objects. I'm making it. Second is same location, same date, minimum occupancy 5, right? This is one way. Another way is, we can have only location and date, and let's not keep the occupancy here. So you can have array of objects here which is having occupancy, just to return these. So if a user is booking from 23rd to 25th, right, so we have in our cache L location 1 for 23, 24, 25, and so on. So what we are going to do is we will fetch the data for 23rd to 25th, and we'll obviously service will fetch this data. Then service will have these, say, 50 hotels or rooms. There can be there will be duplicates in these. So ultimately sorting and merging of this data service can do. That's an easy job to do, and ultimately it will return the response from this. So because you know the location and the date, the data fetching is very easy. Plus, if you remember when I said that our booking subscriber service, which is a worker role, can also update the cache. How that can be done is simply if you if a booking happened, then we know that for location L1 for 23, 24, 25, it has to be continuous, right? Because you are booking with a check-in date and a checkout date. So you know these dates that it that particular room got booked. So you can simply update that those three rows into your cache. So L123, L124, L125, some data will be updated here. So this can be one way of doing it. And because a worker is doing it, so either it can do it in a bulk, means if obviously for same location there are can be thousands of requests. This guy received, though we know our TPS is very low, max 100 TPS, 100 transactions per second. So those, it can club, for every minute it can club those requests and it will dump the data once into the cache. That will be a very good way to do it, rather than updating on every booking, so that you can make sure that there is no issue of deadlock and multiple queues are trying to update the same. So we can club and ultimately transact and dump the data into our cache. So this will enhance our user experience, because then user will be able to fetch the listing page very fast, and our accuracy of showing availability will also be very good here. So overall, on a very high level, this design got updated to this view now, where we will have, for a different type of use case, user scenario, we will have a service behind it, right? And this is rather than the listing service, though listing service can also give the data for one particular hotel, but let's call it a details service, or hotels service also you can say. So it's a detail service which will return you the room types of a hotel, right? So and this DB structure we just discussed, cache we covered, right? And whenever a booking is happening, it is updating the DB. The transaction is happening into one partition now, like we discussed, and then the data is going to Kafka. That particular event is feeding into the Kafka, and your subscribers, there will be different subscribers. I'm only talked about one here, and I think one correction, that this should not go to the replica. This data will go to booking service, will directly dump it to a partition, and from partition it will go to the replica on basis of the database service whichever we are using, right? So they provide this whether to copy the data then and there, or it is okay to be eventually consistent for this data. In this, one thing which we have not covered, so I talked about the transaction, right? That when booking service is trying to update the inventory and try to create the booking for the user, it is updating two tables because now data is sitting into the same database. But what we have not covered is if multiple bookings are happening in parallel, right? And they are trying to book the same hotel, same room types, and for the same room type, you are having one row for the same date into your DB, then how those two bookings, that booking service will update the DB. And obviously, don't just think of it as one booking service, because this is just symbolic. Every component here is scalable, means there is always multiple copy of it running in different regions. So it's possible that one booking service is running in central India AKS, and another booking service is running in you can say US or East Asia, for example, and both the booking service might have received the same request. By that I mean they want to book somewhere in Asia like Bali, right? And they are going to book for the same dates. So both the bookings will try to update same entry into the partition, right? But for different users. In that case, what should happen? Because now your update, so just take a simplest example that your data is like a hotel ID, like we discussed, then room type, ID, then you had available counts, or total count and booked, right? Let's just keep it simple as available count. So when one booking B1 is coming, it will simply try to update it. When a B2 is coming, so let's suppose B1 updated it, they reduce this to 2 minus 2, because a user one in booking one booked this particular room for two different rooms, like he's trying to book 2 rooms, so it will be minus 2. If count was 65 earlier, then it will be 63 now. Same time, booking 2 is trying to do it minus 1. So for this guy it was 65, it will make it 64. And if B2 is happening later, then this is obviously wrong, right? Because now it was 63 already, so it should be 62. So this can happen. So this is again a very standard problem and solution. There are different solutions to it. One best solution which mostly works is think of pessimistic locking here. By that we mean we can do simple one thing, that keep a version here, that what is the version number of this record. Let's say version number is 66, right, of this table, this row in the table. So when booking one is updating this row, first it will fetch the data that okay, I had 65 as count and I'm doing 65 minus 2 as 63, and it will try to dump it. So when it is dumping, a version will be checked that okay, you updated record number 66 and it is still 66, so it will be 67 now. When booking 2 is coming, so it will say okay, you had a version number 66 and in which you are trying to update this number, but here version is not the same as you are saying. So now booking 2, that means whichever service is doing it, it needs to either retry or fail. So in this case we can simply do retry, and there can be again a check that we will do 3 retries. It can be configurable number, and if even after that if it is failing, we can call it a poison request, and we'll return that try after some time. We can return the response to the user that try after some time. So anyways, in a best case scenario, you will fetch the data again, you will have the data with 67 version number, you will update this and try to dump it again. So for 67 version the count was 63, and now you will do 63 minus 1 to 62. So this is pessimistic locking which is required in this design, and this will help us in concurrency when you are trying to book the same thing in the same partition. All right, let's just summarize it and check whether we are taking care of all the non-functional requirement. Means the user experience. That's the most important aspect, right? So firstly, we said that in this design we need high concurrency. In parallel, users are trying to book the same resource, right? So how we took care of it? So we did multiple things. Firstly, we tried to reduce load to different partitions. So we divided our resources in P1, P2 based on the regions. So that way we reduce the probability that multiple people, some people can go to P1, some people will go to P2. That is first, we divided the load. Second, even in partition, what we did is we tried to have different data for different dates when you are booking the resource. So for date 23 for that hotel, data is different. For date 24 for that hotel, the data is different. For 25, data is different. Same in this partition. So that way we further divided. So again, user who are booking on 25th and user who are booking on 23rd, they're anyway divided, so they are not competing for the same resource. Now to the last point, when everybody is trying to book the same date, same location, same room type, same hotel, in that case, because that is our hardest case, right? In that case, we are doing pessimistic locking like we just discussed. So that way we are supporting the concurrency part. Now consistency. For consistency, firstly, because we are doing pessimistic locking, again we made sure that one booking is always happening on updated record. So just in case the availability of rooms become negative, we will simply return a response that this room is no more available, so you have to book it again or find another room. That is first. Plus we do have a sanity check where after some time asynchronously we can confirm, like these advanced systems in market doing these days, that they are not confirming when you are booking, they're confirming a bit later. Maybe that is just matter of seconds or minutes, but that is happening later. So we do have time to do the sanity. Third thing, latency. Like we said, latency, especially in booking, is not a problem. So that we already took care of. That our transactions are happening, data is divided, so you're not searching for the entire 20 million record. You have limited record, and you did partition such a way that even for dates there is different records, so you will be able to search it faster. Especially for listing, because we introduced cache, right? That way we will be able to serve very fast for the users, right? And especially when you are searching for special days, celebrity days, I will call it, like maybe on people are always going out in December last week, right? So that data most probably you will find in cache. So that way our latency will be less. Finally, high availability. Here I talked about that you have to think of, even if some systems are failing, then also you should be able to serve users, right? So that I covered in most of my design, but I will take a moment just to explain that again. Like I talked about this booking service, that this is not a single node, it is not a single point of failure. There are multiple instances. So even if, let's suppose this is central India, here are multiple nodes sitting behind my regional load balancer. And you can, if you are on AKS, then you can think of this your AGIC, ingress controller, right, which is redirecting the load to different nodes in the AKS. So even if this node dies, this will take over, right? So whenever it will come up, ingress controller again started redirecting the data to that redirecting the requests to that particular node. This is first. Even behind it, here you are having a global load balancer where there can be multiple regional uh, load balancers and different multiple AKS behind it. So even in central India, this can be your AKS1 and AKS2. So even if this entire region goes down, here is another one to take to back up that. So that way, this is just your computing. Same for your DB. There will be multiple replicas. I just showed one replica here just for the representation, but there it is not again a single point of failure. There will be multiple, right? Even your replicas. And your partition, obviously replica is there, so that part is covered. And your cache also is a distributed cache, right? It's not one cache. So that way also, even if there is a network failure or some disaster in some of the data centers, other data center instance of that cache will take over. So that way we are making sure our availability of service is not compromised anywhere, because everything is not tightly coupled with anything. So even if one service dies, another can take over because everything is loosely coupled, and another service can fulfill the request on behalf of the first one. So I think, yeah, in hotel booking and listing, this is about it. I have not talked about searching and search by tags, all those things that I can cover in another video. Thank you very much. Have a good day.